I don't think we have to have everything on there. He said in the first meeting that like he didn't even need the recording every week. So
Oh.
I think it's okay if we just keep going where we left off.
Okay. So we were on number 1 of the
Of part
right?
2. Yeah. Okay. Hold on. Okay, the graduate management team admission test. Oh, team. What am I saying? Is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. A, determine the null and alternative hypothesis. So, since we're testing whether or not the score has improved between 529 or like greater or less, so it's like the null hypothesis is the mean equals 529 is equal to 529, and the alternative hypothesis is that mu is greater than 529. And then B, suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. How, or was a type 1 or type 2 error committed? And I said type 1 error. Because they didn't reject the null hypothesis.
See,
Okay,
this
I'm
part
sorry.
is difficult for me. I don't know.
I know, I can't remember it off the top of my head.
Well, what my husband told me, so it's easier for me to remember, is if somebody tells you something that is true, but you felt, wait.
See?
But let me see. So if somebody tells you anything, whatever that you are talking about, but it's true, and you do not believe the person that said whatever it is that they said, then that's type 2. But if somebody tells you a lie, but you believe it as a truth, then that means that's type 1 error, because it was a lie, but you believed it was true. Does that make sense?
Yes, but I'm not sure it helps me at all.
Yes. I think I'll just continue looking at the chart. Okay. So it was type 1, so the null hypothesis is true, but we rejected the null hypothesis.
Right.
Okay. C. If the analysis was done at alpha equals 0.01 level, what is the probability of committing a type 1 error? And it's 1%. So there's a 1 in 100 chance there would be a type 1 error. And D, if we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? And we would increase, because if you increase the level of significance, then there's like a higher chance that you're wrong. Does that make sense?
Yes.
You probably don't need me to explain it to you. I'm more explaining it to myself again.
Okay.
Okay, so for number 2, a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. He randomly selects 15 of his clients who purchase an investment property and obtains the data. So A is to design the study. What is the population from which the realtor obtains his data, and how did he sample this population? What's the research question? So the population is people in his area purchasing investment real estate. And this is who the realtor collects his data from. He collects the data by randomly sampling from his client base. And he wants to know, is the average age of the people buying a second home, a second investment property in his area, different than the national average? So B, collect the data, name at least one way the realtor could have randomly selected a sample, and I said you could draw it out of a hat. It doesn't really matter as long as it's random.
You can also have the computer, like, you know how now you have programs to like do a random sample. It's just like drawing from the hat, but you can do it let the computer do it.
Yeah, if he had more data, I think that would be necessary.
Okay. I just
Okay.
put random sample.
What?
I just put simple random sample.
Yeah, that's fine too. Okay, so 8, think of a couple of examples. Oh wait, well, what am I looking at?
Describe the data.
No, yeah.
Five descriptive statistics.
Yeah, so it wanted us to do it's like a 5-point summary, but they have more than 5 points on theirs. And then describe the data, and then put it on a histogram. Yeah, so that was pretty straightforward.
And so I'm just plugging it into SPSS and then doing all the things to get the mean and the Q plot
Mm-hmm.
and that kind of stuff, right?
Yes.
Yeah.
Okay.
I used Excel, but it's the same thing.
I can't. At least SPSS, something explains it to me how to work it, so I can.
I've just used Excel a lot in the past, so I kind of know how to use Excel, and it's like more straightforward to me than SSPS. So.
Okay.
Okay, so D. One is check the requirements. Since there are only 15 pieces of data, what will you need to check? And then, so they want us to make sure it's normal. So you just make a QQ plot for that one.
Did we decide it? Well, so it's mostly normal? Approximately normal?
Yeah. I thought it was normal.
My histogram, though, is not bell-shaped. Maybe sort of.
Yeah. It's probably approximate.
Okay.
I think you're right.
No, we'll have to say. Oh, I see. You have to check and see if the population is normal, right? There's the.
Yeah, because it's kind of a small sample.
Do you know what the IQR button is for the SPSS program? Emily, do you know?
Where is that at?
Yeah, that's the question. Because I found a range button, but that's not the same as the.
No, I've only
interquartile
used
range.
Excel. I haven't used SSPS very much. So I don't know.
Okay, hold on. What is it? IQR?
Yeah.
Yeah, the interquartile range.
Okay, it's in, Jennifer, if you go to Analyze, and
Uh-huh.
then you hit Descriptive Statistics, and then you hit Explore, and it pops you up the box.
Uh-huh.
If you go down, third from the bottom, it says interquartile range. The third number from
So
the bottom is interquartile range.
the plots.
No, it's in the box. Here, just a minute. I'll share my screen. Okay, can you see it?
Yes.
Okay, see right here it says interquartile range. Isn't that the number you're looking for?
Yes.
Okay. So how I did that is I hit Analyze, and then Descriptive Statistics, and then Explore, and then you put in the variable, and it pops up that box for you.
Because mine pops as the same box, but except for the interquartile doesn't show it. I have to plug it in myself because my program looks different than yours for some reason.
Oh.
Here, let me show you. Wait, let me share the screen. I don't know if you can see. This is how it looks like. It looks gray to me. Here, let me show you. That's what I did. It shows, but I have to click in every single button. See, I click all those, but I don't know why I have 16.
Are you using a Mac?
Yes.
Maybe that's why, because mine is Windows.
Because when I look up YouTube videos for how to use the ASPSS program, it looks way different than my program. And I don't know. Probably because it's a Mac. Because I don't have Windows computer. I have a Google Chrome notebook, but those programs won't work on the Google Chrome computer.
Okay. All right, so I don't know where to tell you to find
I usually do. There's two ways. Usually either analyze the scripture statistics to frequencies or explore, or also if I want a histogram, legacy dialogues and then histogram.
It
And
still works. It still looks
yeah,
fine.
but it's still not showing everything. I had to click on for this box. What's this movie? It it just shows something else like the mean, the median, standard deviation, the skewness, the standard error of skewness. And it says range right here, and but it's not the same as the other one, the IQR, minimum, maximum, and I have to plug in for the quartiles, like 25, that will be the first quartile,
Yeah.
and then 50, that's the second one, and then the third one's 75%. I also clicked on analyze frequencies. It's the same thing as the one you were saying, and then I click on statistics, and this is what I see. For the percentiles, I had to push the button and type it in, and it added. This is how it looks like, and then you just click continue, and it does it. But I don't see any IQR button.
I don't know what to tell you because I don't even know how to work a Mac computer.
I don't know how to use a Mac computer. I'm learning.
Okay.
I don't know.
So then we're on to D.
Yes.
Yeah, we're on 2, D2. So state the null and alternative hypothesis. Is this a one or two tailed test? Oh, I didn't answer that. I only answered state the null and alternative hypothesis. What'd you get for, is it one or two tailed?
For what? D
Well, we have
number
to
2?
decide state the null and the alternative hypothesis. So it's hypothesis is the mean is 47, and the hypothesis Alternative is not, right?
Not 47.
So it is two-tailed.
Yes.
Okay.
Compute the test statistic.
Okay, so for number 3, it was just giving us information, right? Because I didn't do anything for number 3. I just used that number for the rest.
Mm-hmm.
Okay. So for compute the test statistic, was it formula? What is the formula to be used? After writing down the general formula, input the numbers you will use. Show this work. Use Excel or calculator to compute your test statistics. So I got the z-score. Well, the formula is the z equals x bar minus the mean over the sigma divided by n square root of n. And then I got z equals 0.20910.
I used the same formula, but I got something different. I don't know what I did.
Okay, hold on. I'm still looking for all the things to plug into it. I'm sorry this wasn't done before I got here.
Oh, that's fine. I just like to have it done because I don't have to worry about it.
You me too, but I was doing my dumb psychology test.
Mm-hmm. That is more important.
Well, if I can pull out a B in that class, I'm going to be so happy.
What do you put for X bar?
I've got 46.733.
For the X bar?
Yeah.
Why isn't that the mean?
For the X bar, I used 46.73. Is that what you just said?
Yeah, I think I said, that's what I wrote. I don't know if I said it out loud, but that's what I wrote.
Okay.
And for the mu, you put 47?
Yeah.
That's why. I put it backwards. I just put them the other way.
It's confusing where to put numbers. That's like one of the hardest things I've found.
I'm going to double check and see if I get the right answer now.
Okay, I got a negative 0.209.
Yeah, that's what I got. I got a negative, and then I think on the answer key it says it's positive, and I asked my husband to look at it, and he said that I did it right. So I'm like, I don't want to presume that the answer key is wrong, but I did it a few times, and I don't think it's positive.
The answer key says...
What? I got something different.
0.20.
Unless I'm not typing it right or something on the computer. On the calculator, I mean. I got 0.118, but that's not it. And I put the right numbers. I'm going to try again.
So 46.73 minus 47 equals a negative number divided by.
Yes.
Oh, wait a minute. Yeah, divided by 5. 15. Yeah, I get a negative number.
Yes, because you have a negative number when you subtract 47 0.73 minus 47. So
Mhm.
that's gonna be negative.
So our z-score is the negative number?
Yeah.
Supposedly.
So we're saying the answer key is wrong? Somehow
Yeah.
that makes me happy.
I know that's worrying.
Okay.
Okay, now I got the right answer.
What happened? Like why?
Why? Because I probably didn't do it right on the calculator when I plug it in. And I tried twice.
Okay. Okay, so
I probably because it was a nighttime when I was working on it, and I don't think when I'm tired and sleepy.
okay, so our z-score is negative 0.209.
Yes.
Compute the p-value. So then we put in the applet, right?
Yeah. And for P, I got 0.8344.
Hold on, oh, there we go. 0.209.
And so, and on the applet, you shade everything but the middle.
Yes, it's 0.8344.
Everything but the middle? Yeah, so 0.8334. P-value equals 0.8. Okay.
Now they're changing what we called the probability before. Now it's the p-value. Like, let's make this more confusing.
Compare the p-value to the level of significance. So it's greater than 0.05. Do we reject the null hypothesis or fail to reject the null? So with the null is 47.
We failed to reject because the p-value is higher than the alpha value.
Okay.
So 8344 is like 80%, and it's much higher than 0.05. So that means the chances of your being wrong are like really high. Like that's a terrible
Example.
yeah. Okay, so we fail to reject. And then the next one, state your conclusions in terms of the
Wait, we fail. Okay. If we fail to reject it, then we're saying it's true. Right? If
yeah,
we
the original.
it's not true. So are we saying it's true or not true? Okay, see, this is where I get confused. So the statistic, so
Yeah, that means it's true.
Yeah.
So we're saying because the probability was so high, then it is true. So we failed to reject. Okay, I'm sorry, I'm just still catching up. Go ahead.
That's fine. Okay, state your conclusions in terms of the alternative hypothesis. So we don't have enough evidence to conclude that the mean age of people buying a second home is different in this area than the national average.
Okay.
So E says, take action. What action, if any, do you suggest the realtor to take based on your statistical conclusions? And so I said he just needs to keep testing, and he should look at the middle age range for people, especially.
Yeah, because if we look at the histogram, the younger the people, the less percentage that they're buying houses.
Mm-hmm.
Okay.
And that's lesson 9 prep. I'm kind of worried about this quiz because, like, when I was doing this, I was, like, extremely frustrated because I couldn't figure it out with all the different definitions. Like, you had to know all of them and use them all together, so I was, like, so confused. So I don't know how this...
It's the difficult language, I think.
What'd you say?
I think it's because of the difficult language. Like, they're switching up the language on us.
Yeah. And they're introducing a bunch of new stuff.
All right, well,
terms. Okay.
Let's go for it. I have to give my plug. Hold on a second.
There's 21 questions.
Longer than the other one. Number 3, I have the answer. Status quo, that is the null hypothesis.
Sorry, I just turned on another computer and my printer is turning on, so it's loud.
Number 3 is the null hypothesis.
Okay, so a hypothesis test consists of 2 hypotheses, the null and the alternative. Which one represents the status quo? Yeah, I think you're right, because that was like one of the questions on the prep.
Same with number 4, it's the same, the null hypothesis. Because which hypothesis involves equality? Is scary fact? Yes, it's right there.
Which equality is it?
Yeah, you're right. For number 4.
Okay, number 5.
Says,
The p-value is a probability. Statistic at least as extreme as the one that is actually observed. We assume. Isn't 5 the null hypothesis also?
yeah, because
Yeah, the null hypothesis is like the original hypothesis, right? And then you're testing the alternative hypothesis.
that's true.
Okay.
You have the same answer for 3, 4, 5.
He just wants to make sure we got it. Which of the following represents the alternative hypothesis for a two-tailed test? Okay, I say C.
Yes, I agree.
Yeah, you're right. Okay, which of the following represents the alternative hypothesis for a left-tailed test?
I think it's A.
I think it's A. Yeah. And then right's the other way, right?
Yes, so B.
Yeah.
Left is less than and right is greater than.
Yeah. Okay, so 9. Which relationship would result in failing to reject the hypothesis? Okay.
Which relationship would result?
The little thing, alpha, isn't that supposed to be 0.05 or 5%? Yeah, it says right here in my notes. 0.05. You have to have a large number population and normal distribution.
Okay. Okay, based on our homework, we said we rejected the hypothesis because
the p-value is higher.
Because it was greater.
So is it A?
That's what I would say.
Yeah, has nothing to do with this. I don't know why he puts Z for Z-score. It has nothing to do with the question.
So he can confuse you.
So 10 would be the opposite, right?
Yeah, in rejecting. So it'd be greater than A. Or less than A. I don't know.
I think so.
Yeah, I think that's right.
I don't think I completely understand this yet.
It's very confusing.
Okay, 11.
I need to go watch the videos more closely because I watch them, but you have to pay attention to every word, and it's really boring. So I kept zoning out.
Usually I'm okay once I get through the homework. I've worked it a few times. I'm like, okay.
Mm-hmm.
But there's a couple of things that it's just not mathematical. The type 1 and type 2 errors I'm certainly not sure of, and determining rejecting and accepting or not rejecting, I have to,
Maybe,
I have to go back and look.
Maybe if you take notes when you were reading the chapter, that might help. Because I didn't. I wrote it down by hand.
Yeah, I have to do it a few times. I read it several times, but I'm not sure I get what it's saying. That's my problem. So
there's too many words that I'm not that familiar with. For me, that's I read it and I'm I understand 2 words out of every sentence.
Well, they say that the little alpha thing is 1/20. That's 0.05. That means if the p-value is smaller than that, then you're supposed to reject the null hypothesis. So number 10 should be right, unless I'm confused. We'll see at the end.
Okay.
Yeah, I think we got it.
An insurance company is reviewing the current. An insurance company is reviewing the current policy rates. Oh, I'm going on to 11. Is that okay?
Yeah.
Yeah.
When originally setting the rates, they believed the average claim was $1,500. They're concerned that the true mean is actually higher than this. Use the information for questions 11 and 12. Which of the following would be appropriate alternative hypothesis? I say the average claim is greater than 1,500. Number C, or letter C.
Because that's what they want to find out.
Right.
Okay. Yeah, I think that's right.
And then the number 12, it would be the first one. The claim amount is equal to 1,500.
Yes, because that's what I wrote in my notes. Okay. Equals to, that means it's a null hypothesis, and the other one, the alternative, should be either greater or less than. But according to that, the number 11 is C, one greater than.
Okay.
You're good at the ideas behind the math, Jennifer.
Yeah, that's where I struggle. Okay, the insurance company randomly selects 40 claims and calculates a sample mean of $1,650. This information for $1,350. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes, because the sample's large.
It's over 30.
The theorem, what theorem justifies your answer question? Central limit, right?
Yes.
Yeah.
Which of the following is the test statistic as defined by the lesson? Is it Z? Is it Z? Right? Yes. Z is the test statistic.
Yeah.
I think that's right.
Okay. The historical mean of the sales receipts in a grocery store is $150 with a standard deviation of 40. The store manager suspects the average has decreased. She set up a hypothesis test with the following hypothesis. She will use a level of significance 0.5. Then she takes a random sample of 36 sales receipts from her store and computes a mean of $144. Use this information in question 16. What is the z-score with this test? Round to 3 decimal places.
Do we have to find the standard deviation first?
I thought the standard deviation was 40.
Yeah, it says right there, standard deviation 40.
Yeah, but on the prep, I thought we had to find.
Oh, we need the standard deviation of the sample.
Yeah.
So it's the standard deviation divided by the square root of the sample.
But how many samples are there?
36.
36?
Square root of 36. Okay, so did you get 6.666 is the standard deviation?
It's almost Halloween.
Oh.
So you say to find the standard deviation, you put 40 divided by 36?
Square root of
Square root of 36.
Yeah, I know. Square root of 36.
Yeah, I got the same answer, 6.667.
Okay.
Yes.
So let's try this. Okay, I got an answer. I'm not sure it's right, but I got an answer.
What did you put on the top of the equation?
144 minus 150.
Okay.
I got a negative number. I don't know if it's right or not.
I'm almost done.
Mine says negative 0.1499925.
Oh, I might be way off then.
I got negative 5.3997.
So did I.
Well, I put 144 minus 150 divided by 6.667 Wait, let me try again. I'm gonna try it again.
Are we using the long equation with the standard deviation divided by the square root of the sample?
Yeah.
Okay. I think you just need to add one more number in there.
Okay, I got it. Yeah, negative 5.39997.
Okay, I'm gonna try it again. Okay, why you say you got 5.3997?
Yeah.
I got it.
But what does that make our answer? If we round it to 3, that makes it 5.4. That's not 3 decimal places.
I think that's fine. We could put 400.
That's true. For sure.
Okay. What is the p-value associated with the z-score?
Well, that is the z-score though.
Yeah, but we have to get the p-value. What?
We put it in the applet, right?
So it's left.
But you got a positive or negative for the z-score.
Oh, it's negative. I got a negative.
I got a negative.
Me too.
What did we say? Less than is left-tailed. So when we do put it in the probability app, we only light up the left side, right?
Oh goodness. I got an E. Hold on.
I got an E too. But how you gonna let the left side be marked
I
when
know,
we can't even see it?
I think you have to change it to a normal z-score. Oh crap, my computer just died.
That's worse. Did you get 3.1671 E minus 5?
Well, I can't even light up this left side because it's like huge.
Okay, so the probability is extremely low. Let's see.
Well, if I don't light up anything, if I don't put anything blue, then it says something else. One second. It says what? It says 6.6641 e to the negative 8, but that's with no color in anything. Is she gone again? Are you still there, Emily?
Nod your head if you can hear us.
But I can't even see her.
Well, I can see her, but she's frozen.
It's black now.
Oh, now she's gone. We'll see if she comes back. Okay, so when I put in
Hopefully she can finish her test because she said her computer died, and if it dies, it's only one try for the test, the group meeting test.
Oh, that would suck. You're right. Okay, what did you get for an answer?
It says 6.6641 e to the negative 8, but I can't even, if I put the middle part blue, it changes the z-score, but I can't put blue on the left side because it's so tiny that you can't even see it. Does that make sense?
Yeah. Okay, so look what happens when I do this. Hold on, let me. Okay, so when I do this, okay, I'm going to refresh this so it's all fresh, right? Hold on. So there it is. We only want the left side highlighted. So then I put this in at the bottom, 5.3997.
I thought you were gonna put 5.400 by rounding it up.
Yeah, I mean, it rounds it for me, see?
Oh.
But this is what it does. How come it fills in the middle if I have the left side highlighted?
I know.
It's less than 0.999. And then if I click over here, that's the number it gives me.
For mine it says 1 and it highlights the middle part. Let me see.
But then click on the left side. See if it does the same thing as mine did.
1 second. Let me get the app right.
Maybe the highest z-score you can get is a 4.
You're back.
Yeah, sorry. My computer was like dying when I plugged it in, so it like turned back on and everything came back, which is amazing.
Good.
Yeah.
So based on this number that I got right here, if that's correct, then the decimal number is 0.00003161, if that's correct. So the probability is very, very tiny.
Now let me see if I can show you what my computer does. Oh, wait. Materials.
What did you think the z-score was, Emily?
For the z-score I got negative 5.400.
Do you see that?
Oh, I'm sorry, the probability. What did you get for the probability?
Oh, well, I changed it to negative 5.4, and it changes. Oh goodness!
Do you see that?
It changes to 4.
Oh, hold on, Emily.
Mine does the same thing, Emily.
So maybe negative 4 or 4 is like the highest z-score you can get.
Well,
So
mine
we're
got 1. It rounded up by itself instead of 0.9999 something, whatever Carrie got. Unless I'm not doing it right. Let me see. Hers looks different than mine. Is this how yours looks like, Emily?
no. I wait, hold on. Let me see. Well, I highlighted only the left side, but
I can't highlight it on this look.
Well, you have to change it to like a normal one. Like just type in 1 for the z-score and then change it before. Like highlight the right space before and then change the z-score because yeah, you can't see it.
So, but what's the answer? That's what I don't get.
It says 3.3320 e to the negative 8.
See, mine doesn't give me that number.
Really?
No. Is that what you're getting?
Yes.
Yeah, that's what I'm getting.
I'm getting the same.
Well,
Okay.
Carrie,
So,
yours changed to negative 4. Mine actually stayed on negative 5.400.
okay, let me do it again. Okay, so before you put the z-score in, you just highlight the left side, right?
Yeah.
Okay, and then I put in 5.4. And I get 0.99 less, wait.
Because now it looks like it's highlighted in the middle. It did it for you.
Am I still sharing or am I not sharing?
Yes, you're still sharing.
Yeah, we can see it.
That's what I did. So now it's highlighted in the middle, but if I click over here,
Yeah, it changes to 4.
it changes.
Oh, you know what? Maybe it's changing to 4 because if you click on it, it thinks you're clicking on a different part of the z-score and it wants you to change to a different z-score.
Oh.
Maybe you can click on it to change the z-score to a certain number.
Okay, hold on. I still am not getting the same number you guys are getting. It's very annoying. 5.4.
It shouldn't do that.
And even if I take it down, I'm getting this number still, this 3.167.
Your applet's broken.
Great. Okay, well, I'm going to have to go with what you guys say because I don't know what else to do. My applet's broken.
Oh, we still don't know what to type in, so we have 3.3320 e to the negative 8. Do we just type in 3.332 and forget about the e to the negative 8? Because if you compute...
No.
I don't see how can you forget about it when it means that the decimal moves over 8 places to the left.
Yeah, you had to move it to the left eight times.
So rounded to 3 places, it's like 0.000.
Exactly. I think we've had a question like this before where at least I got an answer with an e and I just put 0.000 and I got it wrong.
What is the p-value associated with this graph?
If you want, we can just write it down on a piece of paper as to what we got, and then if we get it wrong, then we can just tell the teacher.
Okay.
So what
I think I'm just going to take a risk and put the actual number.
What, 3.3320?
Yeah. You guys can do whatever you want. I'm just going to write 3.332.
I'm going to put 0.003. I don't know if it's going to make it wrong.
So then, but that affects what inference would you make about the null hypothesis for this problem? Because if we say it's 3.3, then that's different than 0.000, however many zeros, 3.
Oh, that's a good point.
Well, if I put 0.003, that means it's less than.
It's still less than
3%.
Yeah, so we would reject the null, right? Yeah, because it's less than 0.05.
Okay. I'm going to have to make myself some notes. There are so less than is rejected.
Okay, number 19, it says there are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? If you're rejecting,
Type 1.
then it's type 1 because it says it's true, but then you're rejecting it, then that's type 1.
Yeah, like you said about if someone lies to you, but then they're not really lying, or you reject it.
Yeah.
I remembered that.
Well, that's what my husband told me, and it worked. That's how I can remember it.
The researcher decided that instead of using this,
It's like level 1 of rejecting something because somebody says something true, but then if somebody lies to you, then that's twice as wrong, twice as bad. It's okay, so that's type 2. That's how I think about it.
if someone lies to you, it's twice as bad. Is that what you said?
Yeah.
If someone lies to you, they're actually lying.
No, you're right. If you believe a lie, then that's double the error.
Oh, right. Okay, but if
you just
they lie,
reject that and it's true.
Okay.
All right. So number 20. The researcher decided that instead of using level 0.5, he would use 0.1. Which of the following is true? The probability of type 1 error will increase. Okay, wait, this was an error.
Yeah.
I think it's B.
If you decrease the probability of any type. Okay.
Because 0.005, that is the null hypothesis. And 0.01, that will be your alternative. And you're saying that the null hypothesis is false and you are rejecting it, so that is type 2 error, and that means it's increasing. At least that's what I think.
I'm not sure what I think. All right. And 21. A.5 compute the probability of committing a type 1 error.
But then how do you compute it? With SPSS program or just by hand?
I don't know the answer to that.
Did we do this in the prep?
No. I don't remember doing that. Wait, I think, yes we did. Where it said that type 1 error was 0.005 and that's 1/20. That's 5%. And it was part 2, question 1, letter C, and we put 1/100, I think, and it was 1% of type 1 error. That means this one, it will be 5% of type 1 error.
Is that
but
what
I don't know if he wants the probability as a decimal or what, or just put 5%.
I think we should put it as a probability.
But then
So the area, so put it, find the Z-score, and then use the applet. But didn't we just do that?
How do you find the Z-score of yeah, you can't find the Z-score of the whatever this thing, alpha of the significance. How would you do that?
But didn't we just do that for number 16? We found the Z-score, and then we used the applet to find the p-value, and I thought the p-value was supposed to be the probability. Well, I know it's 5%.
Okay, I'm going back to the lesson. Hold on.
Well, I have a note. It says type 1 error, and then the little alpha equals 1/20, and that is 1/20 is 0.05.
Okay, but it still doesn't say how. There's a 1 in 20 chance that it will reject it. So the level of significance A is the probability of committing a type 1 error. So if the question is, where's my question?
If alpha A,
if A is 0.5, compute the probability of typing a type 1 error. the answer's got to be 0.05. That's the answer.
Well, that's what I thought, but I didn't know why I was asking this
And
question.
I'm just reading from the book. The book says,
So do we put 0.05 or do we put 5%?
I think it's 0.05.
Well, that makes it easy.
Yeah, because I remember he said that if it says put it as a percentage, then you put as a percentage. But if it doesn't, then you put the answer as a decimal.
Okay.
Yeah, the ones that he wants as a percentage usually have a percentage sign at the end of the box.
Yes. Let's
Okay.
see how we do
Are
it.
we ready to submit and see how bad it is?
Wait,
Yeah.
number 17, did you guys put 0.003?
I put 0.003. Yeah.
Okay.
I think it's gonna mark it wrong, but I'm going to go for it.
Well, I just don't know. Like, he's never told us what to do with these answers that are crazy like that.
Okay, I'm submitting it.
Okay,
You
wait.
said
Maybe
17?
I was going to say maybe we should
I
put
marked
different for 17. Did you get it right?
No, I marked 16, 17, 18 wrong. I don't know why.
What?
16? How can 16 be wrong?
I know, we all got the same answers. We did it together.
Remember when we refigured the... Oh, wait, where's my work?
The applet. It was the
Remember
applet thing.
when we figured the standard deviation for sample? What if hold on, what if I rework it and don't refigure the standard deviation?
So just put the 40 over whatever instead of doing it. It might change the answer.
Okay, I'll do that and then I'll submit mine.
You're gonna probably get it right. That's my guess.
Sorry, that's my fault.
But it made sense. It's not that it didn't make sense.
But if it still says that it's wrong, if you put a negative, I don't know. We'll see.
Then we'll be really confused.
We'll see what you put and what you get.
Okay, I got the Z-score is 0.9.
0.9?
Yeah. Hold on, I gotta see if it's negative. It's a -9, I'm sorry. That makes it worse.
What if the Z-score is always positive for this or something?
So you're saying positive 5.00?
Yeah, 5.400. What if it's positive? That would give us a different p-value.
Yeah.
I don't know. We'll see what Cherry puts in her answer and see what if she gets it right.
I put my Z-score as 0.90, negative 0.9. Highlighted the left side, it gives me a probability of 0.1841. Where's my test? What did I say it was? 0.1841. 4. And and you said you got 18 wrong?
Yeah.
So that means we failed to reject the null then?
Yes.
Okay, here I go. Ready? Okay, 16 was still wrong, but 17 and 18 were right.
How is that possible? If you get the Z-score wrong, that means the p-value won't be the same.
Right.
Except for my p-value is right, but my z-score is wrong.
That doesn't make any sense at all.
That's not possible.
Maybe I entered it wrong. Oh, I forgot to put the negative.
For what?
I forgot to put the
The
negative.
Z-score?
Yeah.
Okay, can I put it with the negative?
So it's negative 0.900, I think.
So
Okay.
it was just the regular one 44 minus 150 divided by 40 divided by the square root of 36, right?
Yeah. Okay, so put that in and then see what you got, Emily.
Well, I
Okay.
got 87% with 3 wrong.
What
I got-
did you get for the p-value?
P-value is 0.184.
Okay, I'm submitting it.
And then 18 have to be fail to reject.
Oh, you were right.
It's negative?
Yes, it's negative 0.900. Oh, I'm so sorry. It was you guys had it right about the standard deviation. I got a 100.
Yay,
Well,
I
now
got
we know why
95.
now
Sorry.
we know what was wrong.
And I benefited from your
Error.
That's fine.
smartness.
It's just helping each other understand about this lesson.
Yeah, well, at least we know what we did wrong.
Yeah,
That way, when we do the homework test, then we can just.
because I'm not sure I understand everything
Better.
else, but I got that part.
Okay. Awesome. Okay, so I think the tutor wants to meet with us next week. So I have to email her our meeting time. So do you guys want to meet at the same time next week?
Yeah.
I think
Okay.
so. Let me check and make sure that that's okay. Yeah, that's good.
Okay. Awesome.
All right. How did you guys do on your exams? Better than me, I hope.
Bad.
Bad?
Horrible.
Worse than mine?
Yeah.
Oh. I'm
Because I
sorry.
don't know what I did. Because I did my work and everything on my notebook and everything. And I thought I was going to get a better grade than what I got. I thought I was wrong.
How did you do, Emily?
I got a 93.
That's awesome. You must understand better than you think.